Hi, in this video we're going to talk about graphing characteristics. Right? Now, why graphing characteristics are useful are there ways to compare graphs and see what's different and what's important about them. Examples be like, all the different ways that we describe humans as looking different from one another when we're trying to identify them. Right? If you're looking for someone who you have not met before, um, it's often very easy to say, okay, what color hair do they have? What color skin do they have? What might they be wearing? How tall are they? All those kind of things. And they're the ones that people commonly understand, help us identify certain things. Right? Very similar here is graphing characteristics are going to allow us to do things kind of like that. Say, hey, here are the different ways that they look, so we can kind of investigate a little more what's going on there. So starting off with, we have domain. Okay? Domain is going to describe the set of all the possible inputs, or in the case of a graph, the x values. All right. Domain's partner is range, and as you might guess, range is going to be the set of all outputs, or in the case of a graph, the y values. All right. Two other things we're going to look at to start graph characteristics off this year are going to be the x-intercepts and the y-intercepts. Right? They're pretty aptly named, and x-intercept is where the graph hits the x-axis. The y-intercept is where the graph intersects the y-axis. Okay. Look at an example. Let's see what these things look like actual on a graph. So I have here a parabola. All right, now I've got 2 points that are pretty easy to see in here. Define. One is the vertex, it's the lowest possible point of this parabola, and that is the point 2, 2. Right? Another thing we see is right here is 0, 3. We have our 4 things, domain, range, x-intercept, y-intercept, and let's see what we've got. For domain, let's see, I've got arrows going off the graph right here and right here. We got to interpret, what do those arrows tell us? Okay, the arrows tell us that it goes on forever and ever and ever and ever. If we look there, it's not going exactly straight up. It's not going exactly straight to the right. But this one is doing a little bit of both. It's going up and it's going to the right. Now what does that mean? Well, in the graph that means it does that forever. And for the domain, remember we're looking at the x's. So we don't really care that it's going kind of up forever, but we do care that it's going to the right forever. And if it's going to the right forever and ever and ever and ever and never stops going to the right, well, that means that no matter how big of an x value I have, it'll eventually be on this graph. Right? The kind of opposite reasoning goes to this one. Yeah, it's going up, but it's also going slightly to the left, and it's doing that forever. And if it goes to the left forever, well, that direction is toward the negatives, the very big negative numbers, and it goes as far out as possible. The domains are actually all possible numbers, what we're going to call all real numbers. Right, we'll talk about why we say real numbers later in this course. But for now, the answer is all real numbers. All right, let's see if it's the same way with range. So range, remember, is the outputs or the y's. We'll look at this graph, and we've got both these arrows, and they're pointing up, and they're doing that forever, which tells us for this graph, no matter how big of an output you want, if you go high enough on this graph, you'll have one of those. So you actually have 2 of them since they're both going up forever. But the question then is, how small can we get? And we don't have any arrows pointing down, so there is a smallest value. And if we look, it's actually what we call the vertex. It's right here. That's the lowest a y ever gets. So if our y is, smallest one is 2, then we say, well, it's everything that's bigger than or equal to that. Because you can go anywhere above here, and y is included. I'm going to use an inequality to demonstrate this idea, to write this in a kind of very succinct manner, a way that's mathematically common, is y is greater than or equal to 2. So my domain, I can have any number I want. My range, no matter what I put in for my inputs, I can never get a number that's below 2, but I can get numbers as big as I want to. Right? X-intercept, well, see, this is the x-axis right here, and do you see where it hits the do you see where this graph hits the x-axis? It doesn't. Okay? You don't always need them. You can actually have none. So here, very easy. It's none. Move on. Okay, y-intercepts. Let's see, where does it hit the y-axis? Oh, and it's right there. It's that other point that kind of point out to us, and that is the point 0, 3. Now, when you're worrying about the y-intercepts, you should write either the coordinate 0, 3, or if you want to, you can write the value of y. So, or y equals 3. Okay, these both very precisely tell you what they have. The reason we can just write y equals 3 instead of 0, 3 is because if it's a y-intercept, you can assume that the x is 0. All right? But do not, please, please do not write just 3. If you just write 3, I don't know what that means. That's just a number, and it doesn't really describe as closely what we're saying, what's happening on this graph. Okay? Let's look at 2 other examples, and then once you practice, let's erase these. Well, let's set up a new graph. Make this example 2. This one I'm going to give a kind of weird looking graph. So for this example, I have this kind of weird zigzag graph, and it doesn't have any arrows, meaning this is it. It doesn't go on forever. There's not other pieces. We just have this little zigzag. All right. The domain is going to be set up all possible outputs. What x values are there in this graph? Remember, x values go sideways, and so my smallest possible x looks like right there, and that is -2. My largest possible output here, we'll look at the biggest x, and it's, say, 1, 2, 3. So I have 3 as my largest possible, and now the best way probably to show this, or to write this mathematically, would be a few inequalities. Right? So this means that -2 is less than or equal to x. Okay? Kind of flip that around if you want here and say, okay, x is greater than or equal to -2, going backwards. They're all bigger than -2, but they're also all less than or equal to 3. Okay, another way of thinking about what this says here is it says that x, all the values of x here, are in between -2 and 3, inclusive of the different endpoints. Okay, the range, we'll look at that. Say, okay, what's the biggest possible y value? Looks like the highest gets up here is right there, and that is at 1. The smallest it ever gets is right there, and that's at -2. And let's write that the same way we did as the range. The only difference is the numbers according to the graph, and then obviously either x or y because of it's the range. Okay. Last 2 things, we have x-intercept and the y-intercept. So x-intercept, I count 3 of them here, okay? And we can have multiple. We can have none, we can have lots, we can have 1, all kinds of different cases. You just have to look at the graph that you're given. So here I have -2, 0. That's one of them. I have 1, 0. It's a second. And then I have 3, 0. Right, so my 3 different x-intercepts. From y-intercepts here, I only have 1. And that is the point 0, 1, which is right there. It's where my graph intersects the y-axis. Now, it's possible to have more than one y-intercept, but it's not going to be a function. Right? Something to think about, something to figure out. All right, last example. We're going to actually deal with something that's shaped like an ellipse here. So it's like a flattened circle in a way. Let's get that set up. try that again. And this. Right. So example 3 here, we're going to look at something that looks like an ellipse. So we have this kind of shape. Now first we look at this and you might think, that doesn't look very function-like. You're absolutely right. This is not a function. If you do the vertical line test, pop right here and say, oh, hey, if I have the input 1, it's got an output right there, which is like positive almost 1. And I have that output right here, which is like negative almost negative 1. And that's 2 different outputs from one input makes this not a function. All right, good to notice, but it's not actually part of this problem. What this one we're asking is, what is the domain, the range, the x-intercept, and the y-intercept? Right? Domain here, say smallest is -2, biggest is +2. Right? The other thing to really notice here is not only is the smallest -2, the biggest is +2, but it can be anything in between there. Right? For the range, -1 to +1, and then anything in between. Right? X-intercept, well, let's see, we have x-intercepts right at those 2 points, which are -2, 0, and 2, 0. Last one will be the y-intercepts. Put points there, they're below and up there, which gives us the points 0, -1, and 0, +1. Yep. To summarize, we use graphing characteristics as a way of comparing, contrasting, and differentiating the different graphs we have. And this will help us, if we're modeling situations, see what's different and maybe make some discoveries about what's actually going on there. Right? 4 of the main ones that we're going to use throughout the semester are going to be the domain. Domain is the set of all possible inputs, or x values. Range is the set of all possible outputs, or y values. The x-intercepts, where our graph hits the x-axis, or the y-intercepts, where the y intersects the y-axis right there.